What is a flash loan? When you lend money to friends and family, you want them to pay in a flash.
Net to dev.
Sorry, that is not subject for this video. When we talk about a flash loan, we are talking about an interaction between a loan provider on the blockchain that will lend you tokens that you can use to execute any particular trade in a decentralized exchange to take opportunity from an arbitrage. And when we talk about arbitrage, we're basically looking for tokens that are available on DeFi exchanges at a discounted price. If we're talking about arbitrage from a DeFi perspective, we want to, let's say, buy tokens from exchange A. Those tokens are worth significantly lower than on exchange B, which means that I can buy those tokens on exchange A, then sell those tokens on exchange B. I paid the loan that was used to do that trade between exchange A and exchange B and keep the profit. So what is happening in a nutshell is, number one, the smart contract is going to be talking to a flash loan provider. On this video, we are going to be using AAVE as well as Cookbook.dev because we don't have time to code a smart contract from scratch. So what I'm going to do instead, I'm going to head to Cookbook.dev and we are going to look for the AAVE Flash Loan Smart Contract. We are going to be opening that smart contract on Remix, all from Cookbook.dev. On Remix, we are going to be doing the interaction with our AAVE provider. And with that smart contract, what I can do is I can request a loan that must be paid on the same transaction. That is why it's called Flash. It means that it has to be fulfilled, has to be closed, both the lending and the repayment on one transaction. I cannot just request the funds and then use them whenever I like because AAVE is going to go bankrupt. If we allow anonymous users out of the internet request a loan, then what are the guarantees that they are going to pay that loan back? That is why there is a very, very interesting piece of code on the smart contract that allows us to receive that loan. And right after we receive those funds from the loan, we execute our strategy. And this is called a strategy. We need to look where do we see that token that we are intending to buy at a discounted price. And also we need to know where are we going to sell the token once we get the token at a discounted price. So then we earn the arbitrage profit. We earn that difference in price by buying the token at a discounted price and selling it at a higher price. That is the principle of arbitrage. Thing is, with a flash loan, I have to request the funds from AAVE or any other DeFi flash loan provider, executing the first transaction, which will be buying the tokens at a discounted price right after selling them on the destination DeFi platform, right? The DeFi platform that is going to give us a higher price of those tokens. Once we do that, we are converting back those tokens onto the token that was provided on the loan that we told AAVE to give us on a loan. Once we receive those funds, we will repay the loan with the loan fee because that's how AAVE makes the profit. And then what we end up with is the net profit of buying the token at a discounted price using a loan, selling it, repaying the loan, and then what's left, that will be our profit, okay? Once we request the loan, we'll go to the Block Explorer, we'll take a look at that transaction, and you should see the moment AAVE gave us that token loan, gave us that flash loan, and right away, we repay back the flash loan with the service fee. AAVE will charge us to give us that loan. Then once we test just receiving the flash loan, there is one particular section on that smart contract in which we need to set that strategy. The trick on a successful flash loan arbitrage attack is to have a strategy that we can use and apply on the smart contract. What we're going to do, we're going to modify during execution to request that flash loan. We have to insert right in between the moment we are going to be buying the token at a discounted price from Uniswap. Let's say we're going to buy the token from Uniswap. We are going to be inserting that piece of code right there that is going to send the request on that pool to buy X token. Then we have to put another request to sell the token at the other pool swap, right? So in this case, if we're going to sell this on 1inch or SushiSwap, then I have to put the other statement that will execute that sell. Every time that I'm going to be interacting with any pool, I have to pre-approve the pool to withdraw the funds from the smart contract. Remember, the loan gets deposited. It gets transferred to the flash loan smart contract. We receive those funds from AAVE, then we have to allow the swap interface, we have to allow them to withdraw the funds from the smart contract. Alrighty, enough with the talking. Let's go ahead and let's have some fun. Okay, so the first thing that I'm going to do, I need to request test tokens from the AAVE Faucet. If I have to request a loan in USDC, I am going to first request some test tokens because they have testnet tokens that we can use so that we can pay the loan fee, the fee that AAVE is going to charge to perform the flash loan. So I am going to head to AAVE site. So let me go ahead and head to AAVE site right now. I'm going to launch the app. Just connect your wallet. I'm going to select my MetaMask. And what I'm going to do here is that I'm going to head over the Ethereum Sepolia Faucet because I am currently connected on the MetaMask to the Sepolia testnet, right? So I'm going to click here. And what I want to do is I'm going to be requesting some test USDC tokens. Once I obtain the USDC tokens, I'm going to send a small amount of tokens. I'm going to say like 1 USDC or 10 USDC to the Flash Loan smart contract because we need to fund that smart contract so then we can pay the loan, because we need to have some test tokens so that we can pay the loan fee using the token that they are going to lend to us. If we were deploying this on the real mainnet, we will deposit real USDC on the smart contract to pay the fees, right? Because they're going to give us that loan, but we need to still have an overhead of USDC so that we can pay the loan. And you pay the loan using the token that you originally requested on the loan. So if we're requesting USDC, USDT, then we need to make sure that we have enough to cover the fee. They call it the borrow rate. Okay, we can see it right here. I'm gonna put this dark mode, way better. Okay, awesome. So let me head here. Okay, now what you can see, this is a brand new wallet. What I'm going to do, I'm going to request USDC. Let's work with USDC. So I'm going to hit the faucet. And right now, if we just click faucet, we're going to get 10,000 AAVE test tokens, USDC test tokens. Okay, so we're going to click pending. We're going to confirm, and we should be able to obtain those USDC fake tokens. Okay, once that's done, we're going to head to Cookbook.dev. We'll click the AAVE flash loan, and we'll go from there. Okay, awesome. So we have the test tokens. Sweet. Let me click on review transaction details so that we can obtain the contract address. Once we obtain the contract address, I'm going to confirm on the wallet that I have the test tokens. Okay. Wait for this. Boom. I got them. And we can see the USDC. We got 10,000. So I'm going to hit here. I'm going to grab the contract address. I'm going to hit to my MetaMask. And what I'm going to do, I'm going to hit here. I'm going to import the contract. And sure enough, and we got the 10,000. So we're golden here. Awesome. Okay. Next item. Let's go to Cookbook.dev. Get the smart contract. Okay. We're going to head to Cookbook.dev. We can select the AAVE flash loan attacking from here. This is the front page, but I'm going to do a search just in case this is moved. This is the main homepage, so it could move. Okay, so I'm going to go and search for flash loan, and we already see it here. Okay, awesome. So this is the flash loan smart contract. If you are not familiar with Cookbook.dev, it's very intuitive. All I need to do is find the contract that I'm looking for. If I want to learn more about any contract, I'm just going to head over the docs tab. We click here and we can read absolutely everything about the contract functionality. What is each interface going to do on the smart contract? We will have the information right at our fingertips. Okay, beautiful. So that said, I'm going to go back onto the source and sure, I'm going to hit opening remix. So it's going to open a remix page and it's going to ask me that I need to trust Cookbook.dev. It's going to access the file manager in remix. We're just going to allow it. Say remember, I'm going to accept. And now we have the contract. So the first thing I'm going to do, I'm going to go over the contract real quick. The contract is written to mint those test tokens that we need to have in order for us to build the flash loan or to build that transaction to request the lending of those tokens. There's going to be functions predefined on this smart contract that is going to do the auto mint of those tokens and is going to issue that so that we can execute the flash loan. What I'm going to do, I am going to modify this a little bit. Okay, why is that? Because we want to modify this to accept the Uniswap V3 swap interface because we want to also do the arbitrage. First thing I'm going to do, I'm going to test and just obtain a loan. Want to make sure that we obtain the loan, then we will modify the smart contract a little bit more so then we can incorporate the Uniswap V3 swap interface and do arbitrage. Okay, so I'm going to delete this. I'm also going to delete this, which is part of the same function. And this is what I want you to focus on. I want you to focus on the execute operation. This function is the function that we need to modify in order for us to do the arbitrage loan attack. Yes, perfect. I'm going to expand a little bit more, right? So what we see here is that function that I just, deleted to obtain the mintable ERC20 and then the amount to return. What I'm going to do instead, I don't need this. Okay, check this out. I don't need this because I am going to be providing a function. We are going to be adding a function that is going to make the call to the AAVE provider. Again, this is another thing that I'm going to show you. It's going to make the call to that AAVE provider, and the AAVE provider should be able to do the callback into the execute operation and then continue the function. Okay, the callback is going to include those arguments. It's going to provide me the asset. We're going to be providing the amount, obviously, the asset, which is the token smart contract that we are going to ask the loan for, in this case, USDC. And everything else is just going to be provided by the AAVE protocol, okay? So all this information is just going to be auto inserted onto the transaction, okay? So what I'm going to do here, I'm going to just delete this because this is the section right here that I need to insert whatever strategy am I going to do, okay? I am not going to do the mint because, again, this is internal on the smart contract to do the testing by minting the tokens inside the contract. I'm going to approve to USDC that I am going to allow the AAVE protocol to withdraw the funds once the transaction is completed, which means that this statement right here, ladies and gentlemen, is still going to stay. We're not going to move this out of the function because what is going to happen, asset is going to be the smart contract of the USDC tokens. In the case I'm requesting to obtain a loan with USDC. And I am going to be approving what? I am going to be approving the AAVE protocol pool to obtain the tokens back, okay? Because remember, AAVE is going to provide the tokens to us, but we have to allow AAVE to obtain the tokens back. Let's say I delete this function because someone will be smart enough to think that if I remove this function, somehow I'm going to remain with the tokens. That's not the case. This will fail because this is something that is expected to be executed on the call. It's not going to let you do that, okay? I am going to leave it like this. We're not going to do anything. Why? Because right here is where we need to insert that strategy. So the strategy to perform arbitrage is inserted here, okay? So here is the space that we need to use to perform that swap from DeFi swap interface 1 to DeFi swap 2 and do the whole arbitrage thing, okay? So what I'm going to do, I am now going to be inserting that function that is going to make the call to the protocol, to AAVE V3 protocol, and is going to then call the execute operation, okay? So I'm going to go over it very quick. So this function that I just pasted on the smart contract, we just modified the smart contract a little bit, going to request that flash loan. It's going to ask us what is the token address that we are going to be asking for the loan. Okay, so in this case, the USDC token smart contract. Then obviously it's going to ask for the amount. How much are you asking on the loan? 10,000 USDT, 1,000 USDT, that depends on the amount, okay? I am going to tell AAVE the receiver of that loan is this address right here. And again, another thing, if I change this to be my own wallet, it is not going to work because AAVE will know that that address is not a contract that has this function embedded. It does a callback to confirm that this smart contract is the smart contract that is going to execute that function. They're not stupid. I'm just passing those values and declaring type address variable that it's named asset. And then I'm just going to do this function callback to then send the information to the interface to do the actual flash loan request. Once that's done, what it's going to do is going to be executed by the callback from AAVE, and then it's going to give us that loan. It's going to issue the loan to us, okay? And this is where we insert that strategy to do whatever we need to do with those funds, okay? Go ahead and save it. I believe we also need to approve the premium. You know why? Because I need to pay the loan, you know, the total amount that was obtained on the loan plus the premium. So what I'm going to do, I'm going to say amount, and then we are going to be adding the premium, right? So what's going to happen here, it's going to add those two values, and then we will approve AAVE to request those funds, okay? So I'm going to Control S, and that looks good, okay? So let me go ahead and deploy it. Go back. Okay, now the provider. Okay, so now we are ready to deploy, but now the provider, we have to provide the address of the protocol that is going to lend us that loan. It's going to give us those funds. You have to go to the AAVE's website and find the address provider smart contract for the testnet or the mainnet that you're working with. In my case, I'm using Sepolia, so I'm going to head to AAVE. We're going to head over docs. Then we're going to go to developer docs. Let me see where that might be. Testnet addresses. Okay, so you want to hover. Let me zoom in. You want to hover over testnet addresses, okay? And then we're going to scroll down, and here we go. This is the address that we need to find. Pool addresses provider, okay? So we're going to copy this address. Boom, we're going to copy the address. Then I'm going to go back, and we are going to provide the provider address right here. Remember, it's pool address provider. So I'm going to show you pool address provider, okay? And now we're going to do, we're going to deploy it, okay? So we're going to select get the provider, in this case, my MetaMask wallet. And yeah, you should be able to execute the contract. We're going to receive the contract. Beautiful. We have deployed the smart contract. Now that we have the smart contract, I want to confirm that the provider, it's matching my provider, which is the address that I provided right here, 012. Beautiful. And the pool, this is the address that was provided by that provider. Okay, so we have the address provider, then we have the actual pool that was allocated onto the smart contract when we deployed deploy the smart contract, okay? Before we request the loan, we have to fund the smart contract. Remember, that's why we got those test tokens. We are going to be funding this smart contract with a little bit of USDC as an overhead to pay the premium fee, to pay this right here, okay? So let's go ahead and do that. I'm going to copy it over my MetaMask. I'm going to hit tokens. I'm going to click on USDC. Then I'm going to go ahead and send. We're going to be sending to the smart contract address, and I'm just going to send 5 USDC, okay, from this fake balance. So I'm going to say confirm. Beautiful. We have confirmed. Now let's wait, and we should be able to do the loan, okay? Okay, so we got confirmation. We should be good. Okay, so what I'm going to do is the following. I am going to request a flash loan. This is the function, not execute operation. We're going to be working with request flash loan right here. And what I'm going to do, I am going to be providing the token. This is the token that I am requesting the loan for, okay? So what I want to paste that address right here. How do we find out? Let's just grab the token address of USDC and then the testnet. This is the quote, the fake AAVE USDC token. We're going to grab that token address. I'm going to copy it. I'm going to add it right here. And now under amount, I am going to say, we set 1,000. So I'm going to paste 1, 2, 3. That's 1,000. Then because this is USDC, it's 6 decimal places. So we're going to type 1, 2, 3, 4, 5, 6. Okay. That should be it. We're going to transact. And sure enough, here we go. We're going to request 1,000 USDC. Confirm. Once we're done, we'll take a look at the block explorer. The call has been completed. That means that we obtained the loan and we already repaid the loan back. Let's see how that looks in the block explorer. So I'm going to copy it. I'm going to go back. I'm going to head over the Sepolia testnet. I'm going to paste the smart contract address. And we see the contract. We haven't seen the flash loan yet, so let's give it a few. Here we go. We got the transaction. See what we got. Here we go. What do we see here? We see that we successfully obtained 1,000 USDC. That was the loan. Then we repaid back to the protocol 1,000 and 0.5 as the service fee or the premium to execute the loan. Okay, we're good. Now we know that this smart contract, it's able to request loans and it's able to obtain the loan and repay it back. So we are good on this side. Now what I'm going to do, I am going to incorporate the Uniswap interface so then we can do the arbitrage. Okay, now what I'm going to do, swap between Uniswap and QuickSwap on the Polygon mainnet. We are not going to work on the testnet, and the reason why is on Sepolia there is no router functionality, so then we can swap pairs as test, which means that I have to do this on the mainnet, which means that this section, ladies and gentlemen, is costing me money. We have to deploy the smart contract and we have to do the swap, which is going to cost the transaction fee plus the premium fee for the loan. Okay, so what I'm going to do, I'm going to do a swap. We're going to quote, assume that we found an arbitrage opportunity for the WMatic, the Wrapmatic token. We found the token cheaper in Uniswap. So we are going to be buying the token in Uniswap and we are going to be selling the token in QuickSwap because it's a higher price per token, okay? I gotta pre-approve the swap interface to withdraw the tokens from the smart contract, okay? So I have to pre-approve the transfer of the USDC tokens to the Uniswap V3 swap router or swap interface, okay? So let's go ahead. So what I'm gonna do, I'm gonna write it up. What we need to do is we have to pre-approve USDC transfer to Uniswap. Transferring the USDC, remember, we already obtained the loan. Remember, in the execute operation, we already obtained the loan, which means that at this moment, I can use those tokens that were lended by AAVE and transfer them to Uniswap. Once I pre-approve that, remember, it's all happening on the same transaction. I am going to effectively swap USDC to WMatic, okay? Because we found that the Uniswap V3 pool has the lowest price per Matic. Once this execution finishes, now I have WMatic on the smart contract, which means what? In order for me to swap them back to USDC, once we sell them in QuickSwap, I have to pre-approve WMatic to be transferred to QuickSwap. So then QuickSwap can withdraw the funds from the smart contract, okay? Now we are converting it back to USDC by selling it at a higher price in QuickSwap. Okay. Once again, I'm gonna copy this. You're gonna see this on the smart contract. We are going to be pre-approving WMatic to QuickSwap, okay? So we are first pre-approving QuickSwap to withdraw the WMatic from the smart contract. Once that's done, now I can do the opposite. I can say WMatic to USDC in QuickSwap, okay? So now we can perform the second swap and sell the WMatic at a higher price because we found them at a higher price in QuickSwap and we're doing that swap, okay? Once that's done, that's it. We should now allow the contract to repay back to AAVE the loan with the premium, okay? So now at this moment it's pay loan, premium. And that's it. That is high level what we need to do. One thing that we have to also provide on the smart contract is the function to withdraw the tokens, because now we're going to be dealing with the mainnet. The moment I transfer USDC tokens onto the smart contract and I don't have a withdrawal, I lost the tokens. I am not going to be able to withdraw the tokens from the smart contract. So we have to provide that withdraw function. We are going to be adding the function. We will have two swap interfaces. I have to now allow the smart contract with the Uniswap V3 swap interface as well as the V2. Why the V2? Because QuickSwap uses the Uniswap V2 protocol. It's literally the same smart contract. So what I have to do, I have to add to the smart contract both Uniswap V3 and Uniswap V2 protocol interfaces. So then we can do the swap between the two. I have to also provide the contract address for both swaps because we need to tell the smart contract where are we going to be interacting, which smart contract do I need to call to interact, okay? So let's go ahead and do that, all right? Let me go and find the smart contract once again. The first thing, as you remember, we had the arbitrage, we tested all this was good. I am going to be importing two modules for Uniswap V3 and V2 swap interface, okay? So let's go ahead and do that. So we're going to be adding those two imports, the iSwap router for V3. So this will be the router interface for Uniswap V3 and also V2. So we are going to be importing that V2 as well. I will be creating a function to allow me to do that pre-approval, which means that I just have to build an interface, call the IRC20, then use that IRC20 interface. I'm just going to add this here. Okay, so this is just an interface import. And now we have the capability of doing the transfer, balance of, and approve because we need to obtain the token balance. And also we have to approve the two swap interfaces to move those tokens, okay? Both the USDC and the WMATIC. Now I have to define the owner of the smart contract because remember, we're working with the mainnet, which means that I gotta make sure that I protect those interfaces from withdrawal, right? So if I don't set only owner to control who can make that call, that anyone can withdraw the funds out of the smart contract, okay? We don't want that. So we're gonna say address, we're gonna say payable, and we're gonna say owner. Beautiful. We are now going to be initializing that owner. So then we pass the wallet that was used to deploy the smart contract that will be stored as the owner. Type it here on the constructor. We're going to say owner equals what? Equals payable. And then we're going to say message sender. Awesome. That's it. I am going to create a couple of variables that I'm going to be using to store the amount of tokens that I'm going to be transferring, address that I'm going to be doing the swap. This will be the swap router and the router addresses as well. So that we can interact on the functions. And the reason why I'm doing it here is because I will be using those values to call and make the calls on the functions. Okay. Make the calls to do the swap, etc. You're going to see this now. Okay. So I'm going to say address, let's say public, and this address, I'm going to call this swap2. What this is going to do, I am going to be storing the destination variable so then we can pre-approve. So we don't have to like rewrite stuff all over, right? I am going to also provide this will be a unsigned integer, UINT256. I'm going to say public, and this one is going to be the amount out for V2. So this is the amount that I will be expecting to swap in the V2 protocol. So when we do the call, we're going to be storing the value here. And the reason why I'm doing that is because I'm going to use that value so that I can pre-approve that once I need to pre-approve that to be transferred by the QuickSwap interface. And you're going to see this, don't worry. So now I'm going to be passing address public, and this will be the QuickSwap router address. Okay, so we're going to say quick router address V2. And we are going to initialize this with the contract of a QuickSwap. If we go to QuickSwap, we're going to head over QuickSwap router V2 contract and addresses. Here we go. And we are looking for the V2 router address. This is the address that we want, okay? So we're going to copy this. We're going to go back. This will be the router that is going to allow us to do the swap to QuickSwap. I'm going to paste it right here. And now I need to be invoking the Uniswap V2 router interface, and we are going to be passing this as an argument, okay? Check this out. I'm going to say Uniswap V2 because we already imported it, so we have that available. And now I'm going to say public, and it's immutable. I'm going to say swap router V2. Now I am doing that callback, Uniswap. Let me know if you don't know how to do swaps using contracts. I will be more than happy to build a quick tutorial to incorporate swaps onto any contract. And this also allows you to deploy your own ERC20 token, to do the trading and all that. Uniswap V2 router address, and this will be V2. This will be the address that I'm going to be passing on. All right, awesome. So that's done. We initialize the QuickSwap interface. Now we're going to say address public, and we are going to call this router address V3. This will be the Uniswap router address, and this in this case is going to be the Polygon Uniswap V3 address. Okay, router address. Here we go. We got it here. And this is the address. It's going to be E592. So I'm going to copy that address. Okay, I'm going to paste it here. We have to initialize that swap interface as well. So I'm going to say iSwap router. and we're going to call this public. Same, it's very similar to the other one. And this will be immutable. And we're going to say swap router v3. This will be swap router v3. That will be the name of the variable. I am going to now declare the call again, call back that I swap router, and now we're going to be passing the router address v2. Okay, so this is how we initialize those two swap interfaces. Okay, v2, this will be quick swap, and then v3, this will be Uniswap v3. Okay, and what else? It looks like now what I'm going to do right here, this is just going to be very quick. I am going to do a modifier so that we can control with only owner. It's very similar to only owner. Okay, modifier, and we're going to call this only owner require. I'm just going to do a check. I'm going to say address sender. Okay, that is equal to owner. And now if I'm not the owner, just do catch that error, access denied. Okay, that literal tells me go back and continue what you were doing. Okay, now I can inherit this on the function, and it's just like calling only owner to protect that interface. It's literally the same thing. That's good. Okay, so we did that piece. Now what I got to do, I am going to, and I realized that there's an error going on. Oh yeah, because I already imported that. So I created that interface just to do that interaction, because that's the only thing that I need to interact with IRC20. But I believe the interface is still imported, so I'm just going to remove that. Should take care of it. Okay, awesome. Now what I'm going to do, I'm going to build a function to pre-approve. Okay, so this function is going to be internal, meaning that it's not going to be accessible or external. It's just going to be internal. We are going to be using that function to make the pre-approval. Okay, let me write it real quick. I'm going to say function. I'm just going to copy and paste because I have all the contract information here. I'm going to go over it. It's very straightforward. What I'm going to do, I am going to do function pre-approve, right? That function, what it's going to do is going to pass, I'm going to be passing the token smart contract address. This is the address of the token that I'm going to pre-approve to move. I am going to pass the amount that I'm going to be pre-approving and the router address. It could be the Uniswap V3 or it could be the quick swap, okay? Then I'm just going to effectively approve that to do, to pre-approve the contract to move those tokens, okay? The required flash loan is going to stay the same. There's no changes here. Now I have to provide both the V3 swap interface to do the swap and also the V2. So then QuickSwap also is able to do the swap, okay? So check this out. I am going to copy and paste, but this information can be found in Uniswap V3 protocol docs as well as the QuickSwap, okay? So what I'm gonna do, I'm gonna paste it right above the execute operation, okay? So what I'm gonna do here, I'm gonna say function swap exact input single. So if we copy that and we go to our good old friend Google, you can see here that this Uniswap V3 interface, it's the interface that allows me to do exact input swaps, allows me to do a swap between two tokens that I already have the smart contract available or the smart contract address. I'm just going to call that and I will be interacting with the pool right away, okay? So let me go back. And again, on the function, you see that there's a default 3,000 pool fee. That's the 3% to do most common pairs. And this is on the Uniswap V3 protocol. That's the fee. And yeah, this is just information from the iSwap router. This is literally a copy and paste from the docs, okay? This is not like a custom thing done. This is actually what they are suggesting, okay? This is what is on the Uniswap V3 protocol doc. Once we're done with that, I need to also interact with QuickSwap, which means that I have to also provide the V2 interface. So I'm going to provide this right here. Okay, so this will be the function to swap using Uniswap V2, but in this case, I am going to be using QuickSwap, which is the same. It's V2, it's the V2 protocol, okay? Or it's the V2 smart contract. So the same thing. What I'm going to be doing is I'm going to be, by the way, I didn't explain this, but swap exact input single, it's at address from which token smart contract address to which token smart contract address. In this case, as you saw in the whiteboard, we are going to be transferring from USDC, this will be the from, WMatic will be the to. So from token to token and the amount. So what I can do with those interfaces is now I can bring them onto execute operation and do the entire flash loan arbitrage. And the most important thing, there's three more functions, very straightforward. The first two are very, very straightforward. Let me show you. So I am going to, by the way, this is like over here. I'm going to just add a function to allow me to obtain what the balance of the tokens is on the smart contract, so that we know that we got the tokens on the smart contract. Or if we were able to be profitable in this call, we will see how many tokens do we have on the contract, okay? And I'm just going to be passing that token smart contract address of USDC to see how much do we have, okay? And withdraw, this is very important. This one is the one that's going to allow me to remove the tokens from the contract, okay? So I'm just going to pass the USDC address and I should be able to obtain the tokens back. It's basically just calling the interface, obtaining the balance because it's doing that callback here, or it's literally just grabbing it from the interface. and then performing the transfer. Okay, so now what I'm going to do, this function, what it's going to do is going to do the actual flash attack. I request flash loan, but I don't want to modify this. Instead, I am going to be calling this function that I'm going to be providing here. Okay, let's go over it real quick. What this is going to do, remember when we initialized swap2 at the beginning of the smart contract, swap2 is right here. We are initializing this and we are going to be passing the address of the token that I'm going to be swapping to. Okay, listen to me carefully. When I call this, this will be swap2 will be the WMatic smart contract address. That's the address that I'm going to be swapping to. That will be the token that I'm going to be converting to. And then the V2 amount is going to be amount out. Why? This is the amount that we are going to be passing that we should be able to obtain when we do the swap. Okay, if we don't obtain that amount, the transaction is not going to happen. Okay, it's literally going to fail because it has to match this, because that's how we guarantee the repayment to AAVE. Okay, and this will be stored in amount out V2 because I am going to be using this on the other function in the actual execute operation. Okay, and then I'm going to be calling request flash loan, and we're going to be passing the token and the amount. And we can go over here. You're going to see it right here. There you go, token and amount. Let's now finally do this. Let's do the strategy. As we mentioned, first thing I'm going to do, I'm going to pre-approve that USDC to be moved by the Uniswap V3 protocol. Then we'll do the swap. We'll pre-approve the WMatic. We'll do the swap, and then that's it. We're done. Okay. So again, we are calling that pre-approve, which we initialize right here. Remember, we are now passing the token address, the amount in the swap router, or in this case, the swap that I'm going to be interacting. And you can see this right here. We are passing router address V3. Okay, so this will be the Uniswap V3 protocol. Now the second function is going to be to buy. So this will be asset. Asset will be the USDC token. That will be the token that we are going to be using, and we are swapping that to what? To WMatic. Okay, so we are swapping it to WMatic and we're passing the amount. We're going to be providing the amount, which is going to be what AAVE gave us in the loan. Okay, once we're done with that, we're refreshing. We're going to go. We have to obtain what the balance is. Okay, why is that? Let me go back here. We have to obtain the balance. Why? Because we might not have, I'll show you right here, we might not have the same amount, and we're definitely not going to have the same amount of USDC in Matic. Which means what? I need to obtain the balance of the WMatic once we swap and we obtain those tokens on the smart contract, which means now the balance, I need to know what the balance is so then I can ask QuickSwap to swap them back. So now get the new token balance. This will be the WMatic token. And now we need to pre-approve QuickSwap to move them. So let's go ahead and do that. I think it's better just to copy and paste. It's going to be faster. Go back. So we are pre-approving swap2. That will be your QuickSwap interface, the router interface. And then we are going to be passing the balance that we obtain. We verify what we obtain from WMatic and the router of QuickSwap. Okay. Swap2 will be this to balance to here. Okay. This is the address of what? A WMatic. Now I want to pass the balance because that's the amount of tokens that I have in the smart contract that I obtained from that initial swap that I did here. And now the QuickSwap router V2 address. Okay. And now we finally do the second swap back to USDC. Okay, there you go. Okay, and now we effectively are calling what? Swap UniV2. You see the first interface, input single, and that will be right here. Then we are doing swap UniV2, and that will be this one right here. And we are passing from token to token and amount. If we go back here, we are passing from token, from Matic asset, that will be USDC. That was the USDC that we obtained, and balance, the balance that we obtained when we swap to Matic. After that, that's it. We're done. All right, so let me go ahead and Control S. Hopefully there's no errors. There's no errors. You can see that I have like 26 Matic. This is the Polygon mainnet. You can see it right here. Awesome. And I got some USDC. So I think we should be good to do the swap with this USDC. We're just going to request, I don't know, 10 USDC or something. All right, so let me go ahead and deploy. We need to provide the provider address in AAVE. So we have to find the provider for Polygon. Okay, so let me go AAVE. Then we are going to see V3 mainnet. We're dealing with the mainnet. Now we're going to select Polygon, pool address provider. Okay. So this is going to be the smart contract. Let me grab that. Same thing. I'm going to paste it right here. Crossing fingers. Here we go. This is mainnet. Okay, we are getting something. And let me go ahead and confirm. It's going to cost me 12 cents. Confirm. We have deployed the smart contract onto mainnet. Okay, what I got to do is the first thing I want to make sure that I got the provider address and I obtained the pool. Beautiful. I obtained the pool. That means that everything is looking good. I am able to obtain the pool. And I have the withdrawal function. We have the request flash loan and flash attack. We're only going to be dealing with flash attack. Flash attack will do the call to request flash loan and do everything else, okay? Now we are going to effectively do that swap. But first, remember, we have to send USDC to this smart contract because we're going to be paying those premium fees, okay? So I'm going to be sending USDC and I'm going to be sending that 3 USDC. So I'm going to send 3 USDC and hopefully everything is well. Okay, so I'm going to send this. And now we are going to be transferring to the smart contract, 3 USDC. There you go. I just sent 3 real USDCs to this smart contract. Boom, done. Now let's find the balance, okay? Get balance, and we're going to be passing that USDC address, which, by the way, I got to find that here. So view in Block Explorer, and then this is the USD coin, and this is the address. I'm going to copy that address. I'm going to go back. I'm going to get the balance. Beautiful. Okay, so we got the 3 USDC on the contract. Now we are doing the flash loan and we're done. We are going to be opening flash attack, and this is the token that I'm going to be paying with. Okay, in this case, it's going to be USDC. Okay, so let me paste the contract of USDC. Perfect. And now we want to swap from USDC to the WMatic. So let me get that contract address. And yes, this is the Wrapmatic. Okay. So let me go ahead and paste it here. And now what we are going to be providing is the amount that I want to request on the loan. In this case, it's going to be, let's say we are going to be requesting a loan for 10 USDC. So we are going to be converting 10 USDC to whatever amount of Matic do we want. Okay. This will be 10, then 6 decimal places because it's USDC. 1, 2, 3. 1, 2, 3. Okay. And then amount out is when we are specifying that we need a certain amount, right, on the return. But in this case, I don't know how many tokens are we going to receive from the WMatic, because again, this is literally grabbing from the pool, and whichever rate was negotiated or settled, that's the amount that I'm going to receive, which means that I'm going to leave this in 0. This is for us to initialize that router V2, and you can find more information on QuickSwap to do the router V2. And yeah, that's it. Let's set a loan for 10 USDC. And see what happens, okay? So I'm going to transact, and boom, that is good, okay? Awesome, so let me go ahead and execute the flash loan and the arbitrage confirm. There you go. Once we're done, take a look, everything went well. Let's see balance. Remember, it was 3 USDCs, right? Because 6 decimal places. Now let's see how much we have. Ooh, we lost a lot. I lost a lot, okay? So we lost, now it's like literally less than 1 USDC. But this is all because of this video tutorial. So what I'm going to do now, I'm going to show you the transaction. Okay, so let's go view on Block Explorer, and we see some stuff going on. Okay, awesome. So what happened was we got the token, we got the loan, right? We got lended 10 USDC. We were able to swap to Wrapmatic. So we obtained Wrapmatic. Then we were able to grab the Wrapmatic and swap it back for USDC, right? We swapped that to USDC and we were able to pay the loan back. What happened? The entire amount that I have of USDC from the balance, okay? Why is that? Because probably the value of USDC to Wrapmatic on QuickSwap is higher, which means that we obtain less in return. We lost a lot. But again, this is to show you, we were not looking for a strategy per se. We were looking to the functionality on the smart contract to be able to do this kind of swap, okay? That's it. I lost 3 USDC, almost 3 USDC, right? Because it's 7.7. So yeah, literally 3 USDCs, all right? If you like this video, give it a thumbs up. Subscribe if you haven't subscribed to, and we'll see you on the next video.